All right, to get started with statistics, what we want to do is gather lots of definitions. That's going to be the beginning of this course, is defining a lot of things, and then the next few weeks we'll really jump into the math part of it. So first thing we want to do is just define what is statistics. So statistics is made up of a few pieces. It's the science of, and what we want to look at is collecting and organizing, summarizing, and drawing conclusions from data. So it's all going to be based around data that we have. And what we focus on in these first few videos is how do we collect and organize the data. Collecting, it's very important to make sure we have like a well-rounded sample, make sure we have enough information, and then organize in a way that we can analyze it. Summarizing is what we get into in the next few weeks in terms of calculating values. That's where all the math comes in. And then drawing conclusions from the data, like what does it actually tell us? So when we're talking about data, what we need to know is what even is data. So data is any collection of numbers or words, or it could even be images, or any other item that gives us information. So as long as it tells us something, whether we're surveying people or plants or something that's happening naturally out there, but we can be collecting something numerical, which we'll talk about what happens when it's numerical. Words, which we'll call categorical data, what we can do with that. So we have this collection of information. What we also need to think about is where did that information come from? Is it from a population or a sample? And this is something that's going to come up so often throughout the term of difference between population versus sample. If it's population data, that means we have all of the data. That means we talk to every single person or thing and have all of the information, which is a very difficult thing to do. Whereas with sample data, this is just a portion of the population. So this is where we just talk to some people or some things that we interview. And with that, it's much easier to attain, but it's a little less accurate. But if we collect this sample well, which is a lot of our statistics will be around sample data since it's so much easier to obtain, it should be pretty representative of the population. So let's talk about population versus sample in terms of the context of average height of the PCC student. So our population would be everyone. Population is everything, so this is where it would be all PCC students. Every single one of them. Where our sample, if this is our population, the sample is part of the population. It's just a portion of it. And this would just be some PCC students. And it's really up to us or the researcher to choose the sample size, which we'll talk about best sample sizes in terms of having accurate information. We want a decent sample to be representative of the population. We want to be sure to collect it randomly. There are certain things that go into making a good sample. So if we're working with population data, this would mean we would collect the heights of all PCC students and calculate the average. Which sounds pretty exhausting. I mean, if you for a moment imagine that, okay, your project this term is to gather population data, talk to every single PCC student out there in the world, and collect their height, and then take the average of it, which actually taking the average technology can just do for us, but collecting that information is so difficult to do. So what happens with this is really difficult to obtain. However, when you go through this process, once you get that data and calculate that average, if I'm interested in this average height of the PCC student, this is exactly correct. You have all of the information, you calculated it, that's it. So it's difficult to obtain, but it's accurate. That is exactly the value. If we were taking a sample, this was where we would collect the heights of, and it would just be some number of PCC students, and take the average. So this, and that some number is, again, up to the researcher. We could talk to 50 of them, we could talk to 100 of them. So with this, it's easier to collect. If I said, don't talk to every PCC student, just talk to 50 of them, much easier to do. Much easier to email 50 students and get all of the responses than to email every single one of them. So this is easier to collect. However, whenever we use sample data, there's a little error in there. Like, it's not going to be, or rather very rarely would it be the same exact number as the population. But the thing is, it should be close by. So it's easier to collect, but less accurate. And what we're going to talk about later on is if we go through this process of collecting a sample and we make it random, we have a good sample size, this value that we get out should be close to the population average. Meaning, whatever average we would get from the population, this should be close by. In that when we take a nice random sample of, say, 50 students, it most often is representative on a small scale of what's happening within the population in terms of how things average out. So this average height that we'd get here should be pretty close to what's happening in the population. Yes, we can have weird samples, and we'll talk about ways to avoid that, but should be close by. So this idea of collecting averages, that's part of descriptive statistics. These are values that summarize the data. So we can do that with averages, which we'll often refer to averages as means in this course. So we could use a mean. We are going to talk about medians. Those are good ideas of center for our data. And we're also going to talk about spread for our data. So there's something called the interquartile range that we'll talk about, standard deviation. The idea is that each of these give us a number to describe our data. So that's where it becomes descriptive statistics, these different numbers that we can get out that gives us an idea of what's happening within our data. What we eventually want to get to is inferential statistics. This is about generalizing from samples to populations. So this is extremely valuable in the real world because it kind of lets us be lazy a little bit. And so we want to know what's happening within the population. Most likely we aren't going to go out there and grab population data. It takes too much time, money, resources. It's just too difficult. Instead, what we want are these nice representative samples, and then we can make some generalizations from this sample using information about it to talk about what's happening within the population. And this comes through in some sections that we go over, like confidence intervals and hypothesis tests, which those will come in